name is Juan Sebastian Aizcorbe, and I will present static code validation for traits. Right? Well, for those that don't know, what is traits? Traits are new mechanism for sharing behavior different than inheritance. In this way, you compose a class with different behavior blocks. You can compose traits between traits, and also you can compose traits into a class. In that way, a class acquires the behavior provided by a trait. Under this new model, a class can be considered as a superclass plus state plus the behavior provided by traits plus a new code, right? Well, traits has different properties, like flattening property. That means that the behavior provided by a trait is the same meaning, that has the same meaning as the behavior provided in the class. Also, the composition order of the traits is irrelevant, and that means that there is no implicit conflict resolution in traits. So in that way, you have to provide an explicit conflict resolution. It has other properties. This is just a brief review about what is traits. Well, traits is a new concept, so what need the programmers to use traits? Well, the programmers need help to get familiarized with the new concept of traits, and also tools to help to introduce traits in their programs, right? So it would be nice for a programmer having an error detection tools, refactoring tools, composite blind class view, because you have different points of view to consider a class. For example, applying collection of methods, and also you have a composite view that you see the class as a set of behavior blocks provided by traits. So looking at the traits that compose a class, you can have a better understanding about what the class is expected to do. Others, well, what do you need for having a trait error detection tool, right? Usually you can find different errors working, but in that way you will have just a set of different errors without any relationship between them. So in this way to analyze this, we are going to see traits and what specific characteristic has traits, and analyzing that characteristic you can find error types, trait error types, and that way you can classify the errors by similarity or which characteristic is related with that error that happened, right? Well, you will have also a kind of hierarchy of errors, giving you a more meaningful way to understand traits, because in that way you will know about which characteristics are important in traits and what can go wrong with them, right? Well, also... In English, please.
Are you nervous?
Okay, well, after having that classification and those errors detected and typified, we are going to develop or adapt a tool to detect those errors in the code. Well, what kind of errors are we going to search with our tool? Well, the behavior provided by a trait is equivalent to the same behavior implemented in the class. So all the tools to detect or verify behavior are suitable for classes only and classes plus traits. So you don't need actually a dynamic checking code different, because you are just checking the behavior of the system. So any dynamic code checking is suitable for both models. Well, what we want for the tool is to detect or verify trait-specific errors, like related with the specific syntactic and semantic characteristics. Well, what are those syntactic and semantic characteristics? For example, tries definition, try transformation definition, try composition, also error resolution, how we resolve the errors related with traits, and also how the trait is used and how the trait gets linked to the class, is how the class, the behavior provided by the class is attached to the class, the behavior provided by the trait is attached to the class. Those are the specific characteristic of traits that we are going to analyze. Well, this work is based on my master thesis that is coming soon. Well, I'm going to give a brief review about the trait error classes or categories I found, and after this, I'm going to show with more detail about how I adapt smalltalk to check this new kind of errors that are not available to be checked by smalltalk right now, because smalltalk doesn't check after traits, just classes and methods. Well, what kind of what categories we have about trait errors? Well, we have traits and error related with trait transformations, like, for example, trait transformation consistency. That means actually misdefinition about on the trait transformation, like you try to remove a method that doesn't exist, or you try to deep analyzing to two different methods with the same name, that kind of things. Also, message rename, for example. Actually, this transformation doesn't exist in traits, but if you remove a method and also apply an aliasing for that method, it's equivalent to message rename. Also, method of exclusion, like removing a method that doesn't exist, or for example, producing a message not provided to the class, the user class, because you remove that method. You can produce an error trying to making a transformation. Also, you can also try to apply trait transformations in one method class to in a meta class method, or vice versa. So that kind of errors are these of trait transformation related errors. Also, we have trait composition errors, trait conflicts. You want to resolve a trait conflict, or in the composition you produce a conflict. Also, you usually use the transformations to avoid conflicts, but also you can produce conflicts with trait transformation and composition. Well, also traits used are related with how the traits are used, and also with the behavior mechanism. The behavior attached to the class mechanism is, like, for example, overriding. You can override a method of provided by the trait with the same, exactly the same behavior in the class. For example, for example, required methods. You have a required method in a trait that is provided by the class, but because you explicitly declared that required method, you define a method. So that method blocks the inherited method provided by a superclass. In that way, that kind of errors. Well, superset messages. It's like usually it's absolutely legal to send super messages in a trait, but in some cases it's not recommendable because you actually define, for example, you define requirements that the client class of the trait composition has to provide, but here you don't have a way to set requirements on the superclass of the client class. So there is a kind of gray area about how to specify requirements on traits. Next practices is like, for example, some basic things like, for example, define calling traits starting with T or not, that kind of stuff. Okay, well, here we are going to talk about trait error detection tools. Well, we are going to adapt smalling tool to check those errors. Well, we are going to adapt the smalling tool defined for an omni-browser 2 framework, but all the smalling implementations are similar, so most of it should be applicable to other frameworks. Okay, well, smalling, how does it work, right? You have to select some part of the environment to check, right? You define a group of rules that has to be applied to that sub-environment. You define an environment, and that environment means that you have a kind of set with classes and traits inside of it. And then you select that subset of the environment, and you decide to apply those rules on the environment. That environment is also called refactoring scope, right? When you select that environment, you will see a browser with containing classes and hopefully traits included. Well, after that, well, you run the code critics that includes smalling, and that will produce that the selected rules will be checking the classes and traits included in that environment. Well, after that, you will see the screen of smalling with the positive, displaying the positive results of the rule run on the environment. Here we can see that you have, for example, the rules group and the rules instances, and here we see the result of that selected rule. Here we can see that it's not really detailed. Maybe it's sometimes it's enough to see the class or the method where the error is happening, but usually if it is more detailed, it should be more useful because sometimes it's difficult to find the actual error there. Well, what are the limitations of the current smalling implementation? Well, refactoring scope only contains classes. You see the browser that get open when you select what you want to check. You only see classes. Actually, the real environment beside that browser contains classes and traits, but you don't have a way to see that, right? Also, the rules of the smalling framework only take care about classes and classes methods. Here we can see the small checker, that is the class that actually runs the rules on the environment, and we can see that just bypass the threads and check the classes. So we are going to fix that. Also, as we see before, it's a little poor the way that the results are displayed to the user. So we are trying to find a better way to display the errors. Also, many of the errors in traits happen in the trait composition use clause, is where the class declares that we are using a trait composition, and there is not in the class itself, and it is not in the method. So we are going to try to find a better way to show the errors to the user. Right? Okay. Well, what we want on this small extension, as we already talked, factory code must include classes and traits. Rules must be able to check classes and traits, and also the old rules should stay working as before. We are not wanting to break all the previous rules. Also, small browser has to have an extended rule checker and rule results presentation. And also, as a kind of collateral result of this, we are going to have a simplified trait related inspection framework, because there were a common view of the traits and trait composition, and usually traits transformations, and usually you can have a trait in a place where you actually need a trait transformation and also trait composition. You can use a trait as a whole trait composition. So there would be a good thing to have a unified way to inspect that. Well, here comes the heavy coding. Well, refactoring code must include classes and traits. Actually, it already have classes and traits, but you don't see it. So we extended the class browser and we find a new browser that will be open on the browser environment to see all the actual content of the environment, right? Also define a new menu option to include that. Here we have the class name of the new browser that extends the previous one. Okay, here we have the extension, the actual extension of the new browser. Here I'm going to explain a little more about how the browsers work on this framework. This framework will define a metagraph that specifies the data structure, and the browser will try to find the next available data following that metagraph. With that metagraph, we inspect the actual data graph that is the actual model that the browser shows. So the metagraph is the definition of the data structure, and the graph, the actual graph, is the data we are displaying. That graph actually also is like your own model. It's like a kind of, the graph is a kind of adapter from the model you are actually displaying. Well, here we have the previous browser and how the metagraph is defined. Here we see that we'll ask for just classes on the graph or the model that is the environment. And here we have the extension that asks for behaviors. Behaviors is a common definition for all the behavior provider entities like traits and also classes. So in this way, the expected model will include traits and classes. Well, I am not going to go deep in this detail because it doesn't make too much sense. Well, here we have the new menu option for the browsing the environment of the factory scope. And here we can see that include also threads, also classes and also threads. Well, the next step in this adaptation of the smalling tool is make that the rules have to be able to check classes and threads, right? Because before, as I showed before, only check for classes and classes and methods, right? Well, what I decided to do is to keep the previous structure of the rules. The rules define check class and check method for a class, and the smalling checker pass all the classes and methods, including the classes, from the environment, and the results can go to the tool and are displayed. Here we see also that environment only were applied to classes. So what I did to extend the smalling checker was define a way to iterate over classes and threads included in environment, and also differentiating the rules that check threads and check methods for threads also. So in that way, we are going to check individual threads in the environment and the methods belonging to the threads being annexed. Well, okay. Well, next we are going to adapt the actual smalling tool and make this to use the extended result checker. Well, here we can see the extension, the previous implementation, no, it's the new one. And here they say that the checker that is going to be used is the extended one. And also, we have to extend the meta graph defined for the tool for the result display, because in the previous, as we already saw, we only see the content of the results. It's like, for example, you have a positive result on a rule, and the only thing that is done is that class that resulted positive is added to an environment. So the result of a rule is just a bug with a class, no extra information on the rule or what was checked is added to the result. Well, in that way we have to redefine the metagraph for the definition of the structure of the row result that we want to display, and also we are going to adapt the result structure itself, right? And also, well, that is the next thing. We have to adapt the results and the rules to comply with the new result structure. Well, here we have the metagraph of the previous version of smalling and the new one. Here we can see that we have composite rule, that is the group of rules we saw in the middle column of a middle panel, and that is the meta node of the individual rules. And well, when you select just one of the rules, this meta node inspects the attached rule or rule node that actually see on the rule, and you see that in the lower panel the environment associated with that rule and its result. Well, and this is the new metagraph that keeps the previous one for the old rules, And also, here you have the new extended rule meta node that give you access to a more structured way to see the result. The results are going to be displayed as a kind of tree where you navigate on the structure of the traits or the class or the method up to the place where the error happened. Here we have the intermediate nodes, and when you reach the leaf of the tree, you reach that meta node. In that way, in that place, you are going to see the final result in the lower part. All the intermediate step, you are going to see down the lower panel a description of what are you looking, what are you seeing in that node. Well, here is the new structure for the small int rule result, right? Here you have the root trait lead result that is equivalent to an environment, a previous environment where you just have the classes, or the method classes that resulted positive in the root run. In this new schema, you are going, instead of just having classes or methods, you are going to have trading results that are like a tree where you are going to navigate to all the errors detected by that rule. I will go give you an example after this. And here we have the new metagraph model that just model the intermediate nodes for the intermediate steps of the result, and also the leaf or the final nodes on the result display. Well, a little more. Well, we have to develop, or we already developed, mechanism to adapt rule results to this tree-like structure. Well, you have a rule, and actually I'm looking for get a little separate to the previous schema. I want to have a more meaningful result for each rule. So for each rule each new rule you define, you are going to have a kind of object that models that error and what is going on with that, what is going on wrong with that, right? And after that, the rule goes to a kind of trending result builder that constructs what results and that trending results based on the actual rule result. In that way, you structure every result in this new structure to display the result. Well, actually, the result builder is modeled like a kind of chain of non-level builder. Is that, for example, you have a 3 steps build tree, so you are going to have a 3-step builder. So you pass all the result to this first builder, and you will have on the first level of the tree. After that, you pass each group of results to the next level, and you are going to see all the next level of results. So, for example, here you have an individual positive result, and here you have another individual positive result. So, in this way, you display all the results, positive results for this group. And well, you have different builders for intermediate nodes, and also one specific for the leaf to define that that is the last one, the last node you are trying to to construct. Well, here we have what you see after that. Here we have a small int running on factory scope, right? Here we have, it's not really clear, but I will tell you. Trait errors, those are the new trait related errors. Here we have a switched alias with a couple of positive results, 2 positive results, right? Here we have for the switched alias errors a description, right, of what the rule is about, and those are the positive classes and traits where the error was found, right? This is actually the same as the rules before, so if you can also run these new rules on the previous environment, just in case that you don't have all the framework and you don't want to use it. Well, when you choose a rule, you are going to see here switches alias and the classes that resulted positive here. When you select one of them, for example, the description, the behavior where the switched aliasing is defined, right? And you go navigating each level. For example, here is the composition where the error happened. So if you choose this trait, you are going to see another error that is belonging to this trait. And in that way, you navigate along all the data structure up to the individual error, where there you are going to see all the path to the error and where it is actually happening. And down there in the lower panel, you are going to see a complete description of the error and where it's happening and what are the structuring models. For example, selecting aliasing. This is the aliasing that is happening, is making problems. Well, here's the description of the error actually, and here says the aliasing is defined in that class and in the trait composition that that class is using, and also in which trait transformation of that composition is happening. The problem have appeared, right? So here, well, here we see the aliasing that is making progress. Well, also, as a result of this work, we see we get a simplified trait-related inspection framework. Actually, I couldn't use inspector for this structure because it's a really strong name in smalltalk. So, because Hernan told me I am going to use mirror instead of inspector. But actually, I'm inspecting traits and classes, so it's a bad thing. I can use inspector, right? Well, why we need this simplified framework to inspect this? Because, for example, we can use traits and trace transformation and trait compositions in the same role. Actually, we can use a trait as a whole trait composition, and also we can use a trait transformation instead of a trait composition. And well, usually we want to ask the same.
¿Querés terminar ahora?
Okay. Well, we want to usually ask the same things to traits and trait transformation. The things that usually you would like to ask for a trait or a class also are what require messages have, what messages or methods provide to a possible client class or trait, which are the conflicting messages that are in, for example, a trait composition or a trait, a class using a trait composition, and also identify a way to get compiling methods belonging to those behaviors, because classes and traits and trait compositions and trait transformations are behaviors, are something that define a behavior in your model. So it's good to have a unified way to see those behavior common characteristics. Also, there are other characteristics, but this is just a review, so I am not going to read all the detail. Well, as I already told you, each entity, each class defines a mirror or inspector, which provides you that unified protocol or functionality to inspect some of the entity characteristics. These are the mirrors that I defined in this development of systems. Well, behavior mirror, that is just inspecting anything that has method, for example, find a compile method, or which are the messages provided by that behavior. Trait mirror that implements some of the trait-specific characteristics of a behavior. And also trait transformation mirror and trait composition mirror. That trait transformation mirror provides you the aliases that are defined by that transformation. Also the method exclusions that are defined, and I know the messages renamed. Actually, that is a, as I already said, is a combination of a method exclusion and an alias. And trait composition also has conflicts and that kind of things. Which are the conflicts in that composition? Well, this help on anything, will help on anything you want to work in a meta level layer when you are going to work, when you are working on traits or like not just these error checking things. Well, future work for this, maybe studying the refactoring Gaussian grammar to check trait compositions, because the trait composition grammar is a kind of grammar that helps you to find some syntactic things in your classes and methods, but it doesn't define anything about traits or trait composition in a class or trait transformation. So maybe it would be a good thing to have that grammar to help on having an easiest way to define a rule on traits. Also, maybe I think that the navigational way to display the traits or the errors in small entities is not really totally clear. So maybe it would be better to having a kind of highlight of the actual code where the error is happening. It's far more clear than this ad hoc framework to display errors in the refactoring scope. Well, questions?
Have you run Smolin on with your
trade rules on a system or hierarchy with threads? And have you detected errors with that too?
Well, actually, I defined test cases for my own environment and also in the real system, but as you already know, there is not a lot of trade implemented things. So I found a couple of errors. But
what, in yours? In
the small talk image. But also, it's like there are some performance issues, but because all the rules, not only mine, sometimes are a little slow. So maybe just checking a couple of classes take a minute or two or maybe more. So there are some issues. Maybe this also a problem of my rules, but also a problem of the tool that it's not really performant. Well, I hope this answers your question. If you want, I can run.
Is it the control flow graph technique?
What?
Es una técnica, la técnica de grafo de control para hacer análisis estático. ¿Usaste?
No. Well, it depends on the rule actually. But for example, some rules are just checking if there is a method or message name collision, or maybe there is a method provided by a superclass that has the same name as a method or message provided by the try composition. But there is not a specific technique for all the rules. It's just you have to choose what technique you need for each individual rule. And that kind of technique, I think I didn't use. Wow. Okay.